The ties that bind conics algebraically are the presence of squared terms. In fact, every conic section we've studied can be written in the form ax squared plus cy squared plus dx plus ey plus f equals 0. You may have noticed we left out the letter b. This is the coefficient on the bxy term, which describes rotational transformation. You can read about rotated conics on page 757 in your text, should you so desire. It's a short trip from ax squared plus cy squared plus dx plus ey plus f equals 0 to the standard form of equations, such as x minus h squared over a squared plus y minus k squared over b squared equals 1, or y minus k squared equals 4p x minus h. Make sure you know which of those is a parabola and which is an ellipse. To accomplish the journey, we must deploy an old skill: completing the square. Determine what conic is described by the equation 9x squared plus 24y plus 4y squared minus 36 equals 0. Identify all important features of the graph, that is asymptotes, foci, vertices, etc. Now, the first step, if we are trying to get this into standard form, is to combine or group variables that match. So rather than having 9x squared plus 24y, let's write it as 9x squared minus 36x plus 4y squared plus 24y equals 0. Now, the premise behind completing the square is that we will endeavor, where we currently have these two terms, to generate perfect square binomials. We will have to complete the square twice. To do that, the very first step is to factor out whatever is the leading coefficient on our squared terms. So we would have 9 times x squared minus 4x plus 4 times y squared plus 6y equals 0. And I've left these rather suggestive gaps. I'm going to fill these in. I'm going to be adding something in here in order to complete the square. The way that we create a perfect square trinomial that we can then factor down to a binomial is by examining our middle term, that negative 4. We're going to take the negative 4, divide it by 2. That gives me negative 2. We are going to take that object and square it. And the result, we plug back in. So we will say plus 4. Let's take a look over here. We are going to look at that middle term. We're going to take 6 divided by 2. That gives me 3. We're going to take that 3 and square it and plug it in here, plus 9. Now, it is the golden rule of mathematics that whatever thou dost to one side, thou must do to the other. So if we added a 4 here, and if we added a 9 here, it must be that we need to add the same quantities over on the other side. So it's very tempting to say that we would do plus 4 and plus 9 over here. However, my friends, this is wrong. This is wrong because we didn't actually add 4 to our equation right here. What we actually added was a 4 that was then going to be multiplied by a 9. We added a 9 over here that was going to be multiplied by a 4. So in fact, we have added 9 times 4 and 4 times 9. We've added 2 copies of 36. So let's see where we stand at this stage. We've got 9 Well, x squared minus 4x plus 4, that is, as we had hoped, a perfect square. It's x minus 2 quantity squared. And y squared plus 6y plus 9, that is also convenient. It was structured to be, right? It's y plus 3 quantity squared. And that's going to be equal to the 0 plus 36 plus 36, and that gives me 72. This is very close to done. Let's just divide everything by the 72. So that produces x minus 2 squared over 8 after we simplify, and y plus 3 squared over 18. And it's all equal to 1. So we would be well served at this stage to identify what type of conic this is and then to pick out the important pieces of information. We are staring at, if we consider the plus sign in the middle and then look at the fact that the largest term is underneath y, we are looking at a vertically oriented ellipse. Okay, and we can start picking apart the different pieces thereof. So we know that a is equal to the square root of 18, better known as 3 root 2. We know that b is equal to the square root of 8, which gives me 2 root 2. And we would have c squared equal to 18 minus 8, which equals 10. So c would be equal to root 10. Now let's go through and write up our important pieces. Well, if a is 3 root 2, that means that my major axis is going to be 6 root 2. If b is 2 root 2, my minor axis is going to be 4 root 2. If c is root 10, well, I would need to know something about my center before I could really get into the foci. So let's get the center on the page. Center is at 2, -3. We are vertically oriented, so that means that the foci are going to be a shift on the y coordinate. So foci will be at 2, -3 plus or minus root 10. And the vertices will be, again, a shift on the y coordinate. So they will come in at 2, -3 plus or minus 3 root 2. And that's it. That's all we needed to do. We've identified the type of conic section. We have provided all of the important information in the space below our initial equation. This is why we complete the square.